Now we're going to show you how to do the last one, which is multiplying a binomial times a trinomial, or it could be a trinomial times a trinomial, or a trinomial times a binomial. Any of those ways you can use the table for it. It depends on if it's a trinomial times a trinomial, it'll be a 3 by 3 table. If it's a binomial times a trinomial, it'll be a 2 by 3 or 3 by 2. Okay, so no matter what number of terms you multiply, you can always use a table. Okay, so I'm just going to show you using a binomial times a trinomial. Okay, so here, I got a couple here I can do. Okay, we're going to go ahead and multiply a squared plus 3a minus 4 times the binomial 2a plus 3. So I multiply a trinomial times a binomial. You could also have it in the other order. The binomial times a trinomial does not make a difference. So I'm going to go ahead and make my table, and I'm going to choose to do it this way, of the 3 by 2. Okay, so that means that my trinomial needs to, my 3 terms need to go up here, my 2 terms need to go here. So a squared, positive 3a, and negative 4. That is a negative 4, not a positive 4. Here would be the 2a, and here would be the positive 3. And now we just multiply. To get this, we multiply this times this. So a squared times 2a is 2a to the third. Remember, when we multiply the coefficients, but we add the exponents. A squared times 3 is 3a squared. 3a times 2a would be this one. So 3a times 2a is 6a squared. 3a times 3 is going to be 9a. And then negative 4 times 2a would go here. So that's negative 8a. And then lastly, this times this would be this square here. So negative 4 times 3, a rectangle, is negative 12. So now instead of 4 terms, we now have 6. Same rule applies though back when we did the binomial times the binomial. The highest degree is going to be your top left, and that'll be just brought down. So obviously we bring down 2a to the third. And then we also circle the bottom right, because that's our lowest degree. Okay? And then the diagonals, there's now 2 sets of diagonals. If it was a 3 by 3, there would be 3 sets of diagonals. Okay, so obviously here, we're going to circle our like terms. So now we're just going to add these together. Because they're like terms, we add the coefficients. We do nothing with the variable parts. We do not get a to the 4th. So 3a squared plus 6a squared is going to be 9a squared. Then we're going to go ahead and add our 2 other diagonal like terms. 9a and negative 8a. 9a plus a negative 8a is going to be positive 1a or just a. If you want to put a 1 in front of that, that's fine. And then we bring down our bottom right, which is our lowest degree monomial. And if you notice, 3rd degree, 2nd degree, 1st degree, degree of 0. So we have it in descending order, and we obviously can't simplify this anymore because none of these are like terms because they all have different degrees. So therefore, that is our answer. Okay? Should we do another one?
Sure.
Another one? Okay, we're going to do one more of these, and then we'll show you, just to make sure that this table method makes sense to everyone. So I got one more I can do, and then we'll see how we're doing after that.